Okay, so hello everyone. My name is Lohit Goyal and I am from Indian Institute of Technology, Bombay. And today is the live session too. So this week, so you have learned about the numerical errors that we will face while programming in Matlab and how they accumulate. You learned about overflow, underflow, and those kind of things. You also learned about floating point representation, binary to decimal conversion, decimal to binary conversion. So today I will discuss about all those things. So first, so let me just share my screen. Okay, so today, this week was mostly some theoretical work. So today, there will be a small part of coding, that is the bisection method, that will come later. There I will give you first glimpse of how to use loop in a program, and I will talk about detail about the bisection method and how to implement in MATLAB. So first, let's start with few basic examples. The first one is how to convert a decimal number to a binary number. Okay, so here I have shown an example. Just a second. Just let me. Okay, so first we will discuss how to convert a binary number to a decimal number. So here decimal number to binary number. So here the decimal number is given, that is 12, and we have to convert it to the binary number that the computer can understand. So here there are four options: 1101, 1100, 1110, and 1000. So how to solve this problem? Let me use a different color. Yeah. So to solve the problem, you need to proceed like this. This 12. Okay. So 12 divided by 2, you get 6, where 0 is the remainder. Again, divide 6 by 2, you get 3 and 0 as a remainder. Again, you get 2, then 1, then 0. Then here 0, sorry, you get 1 and 1 as a reminder. Then you divide 1 by 2, you get 0 and 1. And we have to proceed like this, we have to proceed like this. So this 0 doesn't mean anything. So we will start from here and go up to this 0. So what will be the answer? The answer will be 1100. Okay, So here I have already solved the problem, and this is the answer. The answer is 1100. So remember, in this case we have to go from bottom to the top. Okay, and this is the correct answer. So option so here option C is the correct choice. So if you have doubt at any point, you can ask me at any moment. Right. Now again it's the same similar problem here. This time we have to convert 19. Okay, so another thing, so at this so let's also do the opposite exercise, how to convert a binary number to a decimal number. So here 1100 is the correct choice, correct solution. Now how to convert it to the binary decimal number? So this is the trick. So it's count like this. It starts from 0, then 1, then 2, then 3. Now 1 into 2 to the power 3, because here the base is 2, because it is a binary number, plus 1 into 2 square, plus 0 into 2 to the power 1, plus 0 into 2 to the power 0. So it gives me 8 plus 4 plus 0 plus 0. So this answer is 12. Okay. Now let's do this exercise. So how to convert 19 to a binary number? So in that case, again the same thing. 19, 2, 9, 1 will be a remainder. 2, 4, 1. This will be the remainder. Again 2, 2, 0. 0 will be the remainder. 2, 1, 0. Then 2, 0, 1. So again this 0 doesn't have any value, so we'll start from here and go up to there. So what will be the correct answer? The correct answer will be 1 0 0 1 1. So this is the correct answer. Now let's check if the solution is correct. So we will start, it will start from 0, then 1, then 2, then 3, then 4. So 1 into 2 to the power 4, plus 0 into 2 cube, plus 0 into 2 square, plus 1 into 2 to the power 1, plus 1 into 2 to the power 0. So the answer will be 16 plus 0 plus 0 plus 2 plus 1 equal to 19. So this answer is correct. So here I have shown the solution in this manner. So when I share this document with you, you will be able to see the solution in the document. So yeah, so now again we have already in the last two examples we have already seen that how to convert a binary number to a decimal number. So let's do this again. So here the binary number is 111011. So what will be the decimal number? So 111011. Okay, so it will be 0, then 1, then 2, then 3, then 4, then 5. So what will be the answer? 1 into 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 cube plus 0 into 2 square plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Right? So the answer will be 32 plus 16 plus 8 plus 0 plus 2 plus 1 equal to 48, 56, 58, 59. So this is the correct answer. Now when we are practicing, let's do the opposite exercise. From 59, let's go back to this number. So those who have joined later, it will help them also. So here we are starting from 59. So those who have joined later, so the last two example was convert 12 to the 12 in the decimal basis to the binary basis, and this will be the solution, this C. And for here convert 19 to the decimal binary basis. So again C is the solution. Here I will again show that how to convert this 59 to the binary number. So here first we have to divide it by 2. Okay, we get the result 29 with 1 as a remainder. Again 2, 14, 1 as a remainder. Again 2, 7, 0, 2, 3, 1, 2, 1, 1, 2, 0, 1. Okay, and we will start count, and we will go, and it will go like this. Sorry. Then we will go from bottom to the top. I mean to count the number. So what will be the solution here? The solution will be here. It will start from here. 1 1 1 0 1 1 1 1 0 1 1. So you can see in this way you can is very easily convert binary number to decimal number. Also the decimal number to binary number. Okay, I hope it is clear. Okay, now let's try this. Okay, I'll give you some moment to think about it, then I will solve it. So here there is some ABCD or some number, maybe 1 or 0 something, okay, equal to some n max in the decimal basis. So find ABCD such that we get a maximum value n max on the right hand side. Find the value of n max as well. Okay, so the question is, A can be 1 or 0, B can be 1 or 0, C can be 1 or 0, D can be 1 or 0. Okay, so you need to find what will be the value of A, B, C, D such that this value on the right hand side, which is n max, with it I mean it indicates what it means. So on the right hand side we get a maximum value, and also you have to find what is the maximum value. So take a few minutes and come up with an answer. So what will be the solution of that? So here there are four options you can see.
Sir, option C.
Option option C. Yes. So option C will be the correct answer. So now let's give you the solution. So what is the case? So A, B, C, D, they all can be either 1 or 0. Okay. So obviously it will be, what is the conversion rule? So see any previous example. Maybe this one, 1100. Right. When we try to convert it to the decimal number, so it will be what? So it will be, suppose we want to convert this 11002 to some decimal number. Okay, so it will be 1 into 2 cube plus 1 into 2 square plus 0 plus 0. So these zero numbers contribute nothing. So the obviously this number will be maximum when A, B, C, D, all of them are equal to 1. So A equal to B equal to C equal to D equal to 1. Only then the right hand side will be maximum. If any of them is 0, then that is not a maximum value. Now if we convert it 1 1 1 1 to some 10, some push 10, so what? One second. So if we convert it 1 1 1 1 2 equal to some number, so what will be the number? So it's the first, this is the first term, its power will be 0, then 1, then 2, then 3. So 1 into 2 cube plus 1 into 2 square plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. It will be 8 plus 4 plus 2 plus 1 equal to 15. Okay, so this is the correct answer. All right. So, so here is another question. So this is again in the binary basis. Okay, and on the right hand side, we will get we will get an even number. So the question is, what will be the value of d so that we get an even number on the right hand side? So here is only actually two options. Okay, so d can be either 1 or d can be 0. Now you have to estimate. Now for when we will get an even number on the right hand side. So is it d equal to 1 or d equal to 0? Again, take a few
D
minutes.
is equals to 0.
D equal to 0 will be the answer. Now, so what will be the reason? So, yeah, so let's take some exams. Oh, just a second. Just let me save the session. Yeah. So let's take some examples. Okay. So okay, let me do it at the end. So A, B, C, D to equal to some n even base 10. Okay. Now again, what is the formula to convert it? So it will be zero. It will be 0, 1, 2, 3. So answer will be a into 2 to the power 3 plus b into 2 square plus c into 2 to the power 1 plus d into 2 to the power 0. So a, b, c, d can either be 1 or it can be 0. So it will be 8a plus 4b plus 2c plus d. You see that this is an even number, right? This is already even number. Now if d equal to 1, then this number will be odd, and d equal to 0, then this number will be even. Okay, so d equal to 0 is the correct answer. Only then you will get an even number on the right hand side. Similarly, when d equal to 1, then you will get an odd number on the right hand side. Okay, now let's solve some complicated example. Okay, so here these are the so so how to convert this from decimal to the binary number. Okay, just a second.
Option A.
Huh?
Option
Option
A,
A.
sir.
Option A. Okay, so let's solve it. Okay, so 131. Okay, 2 65 1 2 32 1 2 16 0 2 8 0 2 4 0 2 2 0 2 1 0 2 0 1. So what will be this part? 131. It will be 1 0 0 1 2 3 4 5 5 zeros. 1 2 3 4 5 1 1. Okay, so this is the 131 part. Now 0.25. So how to convert it to the decimal number? Here we have to multiply it, equal to 0.5. Here we will take the left hand side, 0. Sorry, so the we will take what is available before the decimal, and 0 is available before the decimal, so we are taking 0. Again, 0.5 into 2 equal to 1.0. So here I am taking 1. Now here I am left with only 0. So 0 into 2 is equal to 0. So we do not need it. Okay. So here this will be the number. So for 0.25, 0.25 base 10 is will be equal to 0.01 base 2. So what will be the complete correct answer? The complete correct answer will be 150.01. Yeah, so then option A is the correct option. Okay, so let me just repeat again. So you already know how to convert 131 to the binary number. Okay, we have already solved 5 6 examples on that. Now we have to convert 0.25, which has a decimal, which is on base, which has a base 10, to the base 2. So here instead of dividing by 2, we have to multiply it by 2. So 0.25 is 0.5. Here we will take this part 0. I have taken this 0, and it will left with 0.5. So 0.5 into 2 equal to 1. I have taken this 1, and then I will be left with 0 only. Then 0 into 2 is equal to 0. So 0 1 0. Here the 0 has repeated again. So we will consider just first these two number. So the correct answer is this, the complete correct answer. Okay. So 0.25 base 10 equal to 0.01 base 2. So option A is the correct one. Okay, so when I share the sheet with you, you will find the solution over there, and you can, if you have any doubt, you can practice it and practice it. Okay, now we have to do, okay, we have to do the opposite exercise. So so this is in binary. We have to convert it to the decimal. Okay, so what is the number? So first do step by step. 1110. So the the first power will be 0, second 1, third 2, then 3. So answer will be 1 into 2 cube plus 1 into 2 square plus 1 into 2 to the power 1 plus 0 into 2 to the power 0. So it will be 8 plus 4 plus 2. 8 plus 4, yeah, plus 2 equal to 14. And what will be 0.011? 8 plus 4. Yeah. So what will be 0.011? So it will be, so it's the power counts here like this. This is -1, this is -2, this is -3. Okay. So the answer will be, so here we will get 0 point. So the point will be outside. 0 into 2 to the power -1 plus 1 into 2 to the power -2 plus 1 into 2 to the power -3. So we will get 1 by 4 plus 1 by 8 is equal to 0.375. So here I have mistakenly written it like 12, so it will be the 14. Okay, so the correct answer will be 14.375. So let me go through it once again, especially the second part. So we already know how to convert this 1110 to the decimal number. Then this is straightforward, 14. Now for the second part, we have 0.011 on the 2. So how to write it? 0.011. So after this point, okay, the power will appear as an inverse. So it will be this is the, so here we have started from 0, okay. Then obviously on the right hand side, it will come like 2 to the power minus 1, it will come like 2 to the power minus 2, and it will be 2 to the power minus 3. So the answer will be 0 into 2 to the power minus 1. This 0 is coming from here, plus 1 into 2 to the power minus 2, plus 1 into 2 to the power minus 3. If you calculate, you will get the answer is 0.375, and it has a base 10. Okay, so this is so 0.011 base 2, it will be 0.375 base 10. Okay, so here we have, so what will be the complete solution of this answer? So for the this first four thing, we get the solution 14, and for this we get a 0.375. So option 3 is the correct choice, 14.375. This is the complete answer. Yeah, I made a mistake. This will be 14, this will be 14. Okay. Okay, so now let's move on to a new topic. So significant digits. Okay. So the question is, how many significant digits are here? So can anyone answer? There are four options.
Six. Six,
Six.
sir.
Yeah, okay. So how to do that? So here the number is 131.012. Now in order to find a significant digit, we have to go to the normalized form, and that will be 0.131012 into 10 cube. So here there are 1, 2, 3, 4, 5, 6, total 6 significant digits. Okay, all right. Okay, now answer this. How many significant digits?
Four, sir.
We have 4 significant digits. Now here, how we can write it? 0.007900 is equal to 0.7900 into 10 to the power minus 3. Sorry, 10 to the power minus 2. Here, remember, you have to count these digits as well as the significant digits. Before, so the preceding zero, they do not add up as a significant figures, but the trailing zeros, these two, they will, you have to count it as significant figure. Okay, so here the correct, so here the correct significant digit is 4. So the answer A will be the correct. Similarly, if you have some problem like 0.000131, here you will have 4 significant digits. Okay, so if another 20131, so here will be 6 significant digits. So you do not care about this preceding zeros, but you have to count this trailing zeros. Okay, so remember that. All right.
Sir, can you explain that once again, sir?
Sure, sure.
When we can leave the trailing zeros, sir?
In order to count a significant digit, suppose, let me explain by an example. So 0.00001, yeah. So we can write is that 0.1 into 1, 2, 3, 4, 5 into 10 to the power minus 5, right? Here the significant figure s is equal to 1 only. Okay, now you have something like this, 0.100000. Okay, so we can write it as 0.100000 into 10 to the power 0. Here your
Okay.
significant digit is 1, 2, 3, 4, 5, 6, 6. Okay, I hope you understand now.
Sir, usually we convert any fractional number to normalized one, right?
Yes, 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 yes,
It should
yes.
be between 0.1 to 1.
0.1 to 1, right.
But you showed two examples, no sir, before with 0.7900 you showed one. Another example you pick with 0.0003 with the trailing zeros 0003. That I didn't understand, sir. To
Uh,
count the
which,
significant digit. You
which
took
one?
the example of 0.0003 and triple zero.
Point triple zero three. Point
You
triple
took
zero.
with this example, sir. You explained with this respective ninth problem you took just now.
Okay, okay. So these two.
Not that, sir. Previous, when I asked the doubt, no, you had taken, just take the number, sir. Point
Huh?
triple zero
Huh?
three
Three.
triple zero. For
Okay.
this,
Okay. Yeah. So how we can write? So how can we write it? First of all, so it will be 0.3123 into 10 to the power some q. Q may be -4, -5. Okay. So here we have total four significant digits. See, here there are three preceding digit, three preceding zeros, and here three trailing zeros. Okay. So
okay, sir.
you might get confused that only three is a significant digit, but no. These three we will not count as significant digits, but these three zeros will be counted as a significant digit. So total number of significant digit will be four. Okay, just
So
convert. Huh.
you mean to tell I can write this form as 0.3000 into 10 power 3.
10 to the power it will be -4, I think. It will be
Minus 4,
10.
sorry, minus
Yeah.
4. Huh.
Yeah. Huh.
Okay.
Then here then there are will be four significant digits.
Yes, sir. So answer is 4, sir.
Huh, answer is four for this question.
Okay. Thank you, sir. Thank you.
Okay. So now the floating point arithmetic. So we have to so here there is this is a 8 bits a number. So you have to represent 111.2 using this above diagram. Okay. So first let me give an give it. So I have done the solution. Let me explain it, then you can try the next one. So here the first one will be the symbol. The first one will be the symbol of the number, either plus or negative minus. For positive it will be 0, for negative it will be 1. Then this four number, this will be the part of the mantissa. This will be the part of the exponent, the sign of the exponent. If it is the exponent, if the sign of the exponent is minus negative, then it will be 1. If it is positive, then it will be 0. And this two is reserved for the expression of the exponent. All right. So just use let me use different color. So this is for the symbol of the number. Let me write SN. These four are for mantissa. Okay. This is for the symbol of the exponent XSE, and these two are for the expression of the exponent E, capital E. Okay. Yes, Shoham.
So what is mantissa? That four portion
Yeah.
containing.
So if you Mantissa, so if you probably it was in the third lecture most probably. Okay, so Mantissa is the main body of the number. Okay, so here the number is 111.1 base 2. So here the Mantissa part is four ones, 1111. So this is the base part. Okay, so this is the main body of the number you in common word. So just go through probably in lecture 2 or lecture 3. Here the definition of mantissa is explained very clearly. Just go through it. Okay.
Okay, sir.
So here this, so we have to now express this number. Okay. So how to proceed that? So we can write it as 0.1111. So we are converting into the normalized form. 1111 into 2. So here, okay, so let's understand this. So in case of a decimal number, normal decimal number, so if I have a number like this, so 100.37. Okay, so for the normalized form, how to represent that? It will be 0.10037 into 10 to the power 3. All right. So here you see, here I am as the, sorry, as it is in the decimal basis. So here, so that's why this 10 appears. If it is in some other basis, probably some arbitrary number basis, that arbitrary number will appear here. Okay, so we can express any number in decimal in this form, and this 10 appears because it is a decimal number, the base is 10. Now here, this is a binary number. So what will appear as the base? So it will be 2. Okay, so it will be 111.1 is equal to 0.1111 into 2 to the power 3. Now remember, this 3 is in the decimal basis. Okay, just like this. Here we write this 10 cube. It is 2 cube, but this is not 8. Here 3 is on the 3 is in the decimal basis. Okay, so first you have to convert this 3 to the binary basis. So how to do that? 2, then 1, then 1. Okay, so 3 base 10 equal to 1 base 2. So if you have any doubt, so this is a little complicated. If you have any doubt at any, you just stop me and ask question. So how we can, so what will be the final answer? The final answer will be 0.1111 into 2 to the power 11, and now it has the base 2. Now this number is completely in binary basis. So again, so how to write the number? So first one is the symbol of the number, and the symbol is positive. This is not a negative number. So 0 appears over here. Now, Shoham, as I have told that the mantissa is the main body of the number. You see that at the mantissa part, the four bits are reserved for mantissa. It is 1 1 1 1. All right. Now in the space of the now for the case of the exponent, the exponent is here is positive. This is not negative. So for the positive part it appears 0 over here, and now the only the expression of the exponent, that is 1 and 1. Okay, let me go through it once again. So this is the diagram for a 8-bit number. Okay, so we have to represent 111.2 using all these 8 boxes. Okay, now the first box is reserved for the sign of the number. This sign will be this value will be 0 if the sign is positive. The value will be +1. Sorry, the value will be 1 if the sign is negative. Now these 4 boxes, they are reserved for the mantissa part. The mantissa is the main, you can think like a main body of the number. This one box is reserved for the sign of the exponent, like 10 to the power 3. Here 10 to the power the cube, that means 10 to the power +3. For this plus sign, it will take 0 value, and 10 to the power -3, for this minus sign it will take 1 value. Okay, then these two are reserved for the expression for the exponent. Suppose here 3, now it is in the decimal basis. Now if we convert it to the binary basis, it will be 1 1. If I have 2 10 square, so 2 10 to the power 2, so this is again in the decimal basis. If I have to convert in the binary basis, it will be 1 0. Okay, so this value will appear over here. Now the solution 111.2. Now here we always have to convert it to the normalized form. So here, to convert it to a normalized form, like I have told, that suppose I have a number 100.37. Okay, similar to this number 100.37, we can write in the normalized form 0.10037 into 10 cube. Okay, similarly in this case we can write 0.1111 into 2 to the power 3. Now remember, this 3 is not in the binary basis. This 3 in the decimal basis. We have to convert it to the binary basis. So if we convert this 3 to the binary basis, in the binary basis 3 is 1 1. So we can express complete. So this is the complete binary form, and this is 0.1111 into 2 to the power 11. Now sign, the sign of this thing is zero, positive. So so zero appears on the first box. Then the mantis part, the main structure, the four ones, 1111, they appear here. Again 10 will be appear, 10 will appear here, because this is the sign of the exponent, it appears here. And here this 1 1 is at the expression, is the expression for the exponent. Okay, so I hope this is clear by now. So still, if you have any doubt, you can ask me. And let's go. Okay, now let's try another example. Okay, suppose we will solve the 11. Okay, one second. So let's try this example. 100.1. Okay, so how to represent that? Okay, no, that's 10.01. Okay, let's convert it to this format. So our number was 10.01. Okay, so how we can convert it? So first step, we have to convert it to the normalized number. So it will be 0.1001 into, sorry, not 10, this is in the decimal basis, it will be 2 to the power 2. Now this 2 is in the decimal basis. We have to convert this 2 to the binary basis. It will be 0.1001 into 2 to the power 10, and it has the base 2. Because if we convert this 2 in the decimal basis to the binary basis, it will be 10. Okay. Now I have to write it in the 4 boxes. Sorry, in 8 boxes. The first box will be 0, because this is a positive value, 0. The next 4 boxes will be the mantissa, 1 0 0 1. Next box will be the sign of the exponent, that means here it is positive, it will be 0. Okay, and next 2 will be reserved for the expression for the exponent, that is 1 and 0. All right, so this is this is the answer. Now suppose this number is minus, what will happen? In that case, a 1 will appear here. All right, okay. Now I hope the idea is clear, how to do this kind of problems. Now okay, so let's solve this problem. So represent 3.2510 base 10 in this format. Okay, so now how to do this? So can you try this? So previously it was in the binary basis. Okay, now here it is in the decimal basis. So first you have to convert it to the binary basis, then you need to solve the problem. So can you try this for a few minutes? What will be the answer for this?
0 1 1 0 1 0 0 1.
So tell me again. 0 1 1
0 1 1 0 1 0 0 1.
0 0 1. Okay, so let's solve this. So okay, one second, uh, s- let me save the recording.
Sir,
Yes, Rom.
sir, I am getting the last two digits as 10.
Okay, we will solve this. Just a second. Huh? Okay, so let's solve the problem. So the number is 3.25. So for 3, it is very easy. 1 base 2. We have already done it. Now for 0.25, first multiply by 2, 0.5, 0. So I am taking 0 from here. So again 0.5 into 2. If I am getting 1.0, I am taking 1 from here. So the number is 11.01 base 2. All right. So what will be the now? So the first step will be uh, go to the normalized form, that is 0.1101 into 10 to the power, sorry, 2 to the power 2, where 2 in the decimal basis. So in we have to convert it to the binary basis, then it will be 1101 into 2 to the power 10 base 2. So in the 8 bits format, what will be the case? The first one will be 0. That is the sign of the number. It is positive, so it will be 0. Then the mantissa part, 1101. Okay, again the sign of the exponent, it is again 0, 0, 1, 0. So 0, 1, 1, 0, 1, 0, 1, 0. So you are getting this answer, Shoham?
Yes, sir.
Yeah. So Teja, you might have made some mistake somewhere.
Yeah, sir, I committed mistake.
Hmm. Yeah. So this is the answer. Okay. Now let's solve. Now let's go to the error part. The chopping error. So first one is the example of an absolute error. Okay. So suppose x1 is rounded to 3 decimal points and corresponding absolute error is 0.0073 into 10 cube. Similarly, for another number x2, the corresponding absolute error is 0.0017 into 10 cube. Now, what will be the maximum error if we add these two numbers? Okay, so you have one number x1 and another number x2. Now we are getting, so we cannot, so suppose there are some error representing the number completely, so we are only getting an approximation of this number, that is x1 star and x2 star. So it is given that x1 minus x1 star, so the modulus value, that is the AE1, equal to 0.0073 into 10 cube. Similarly, x2 minus x2 star equal to AE2, that is the absolute error 2, is equal to 0.0017 into 10 cube. Now when we add these two numbers, so did I mention addition or subtraction?
Addition, sir.
Addition, okay. So when I add these two number, okay, the resultant number, so the resultant error will be x1 plus x2 minus of x1 star plus x2 star. Okay, so we can write it like this: x1 minus x1 star plus x2 minus x2 star. Now from the triangle inequality, it will be so here the maximum value will be just addition of these two, 0. So the answer will be 0.0090 into 10 to the power 3. So this will be your final answer. Okay, just very straightforward question. Okay, let's go to the next question. Right. Yeah. So suppose x star is an approximation of x which is corrected up to n digits. If rounding error is equal to x minus x star is less than or equal to a into 10 to the power minus 9, and chopping error is equal to chopping error equal to is less than or equal to b into 10 to the power minus 9, then which one is true? Okay. So if you go to the lecture of the rounding error and chopping error, you will find that this will be the correct choice. So it will be the case where the rounding error is always half of the chopping error. So you get better. So you get better accurate. So you get more accurate result in case of rounding a number rather than chopping. Okay. So from that part, you will get that this answer is the correct one. Okay. So now I will do some discussion about what is the truncation error. Okay. So in the last class, I have shown one example in where when I was do some exercise on plotting. Okay. So it was the exercise was e to the power x equal to 1 plus x square by 2 plus dot dot dot. Okay. So this is an infinite series. Now, so from the plot we have seen something like this. So this is the x, this is the e to the power x. Sorry, this is the y. So I have plot 1 plus x, 1 plus x square by 2, and 1 plus x square by 2 plus x cube by factorial 3. So suppose this is the original curve. Suppose this is the, no, it will not pass through 0, sorry. So this is the original curve. Okay. So we have seen that up to some distance, the 1 plus x agree very well. Then again up to some, then after up to some distance, 1 plus x square agree very well. Then it suppose maybe it diverges like this. Then again up to some point, 1 plus x cube agree very well. Then again it diverges. Okay, as the x value of the x increases, the none of the approximation works. Okay. So here at some point we are truncating this expression. Okay, so we are telling that we are telling giving the information to the computer that we don't go any further beyond that, because we cannot give an infinite expression to the computer. We have to stop somewhere. Suppose that n equal to 100, where n is the number, where n is the number of elements in the summation series, we have to stop somewhere. So I am telling that computer that up to n equal to 100 I will calculate the summation, then after that I don't need any other value. Okay. So then what will be my truncation error? My truncation error will be, so suppose n equal to 100. Okay. How can I express this in terms of summation? Equal to I equal to 1 to n. This is our approximation. Okay. I equal to 1 to n x to the power n by factorial n. Yes, I think this is correct. 0. Yeah. So it's so sorry. I equal to 0 to n. This will be x to the power I by factorial I. Okay. Then there will be some other digits left. So that will be I equal to n plus 1 to infinity x to the power I by factorial of I. So I am telling computer that I want to stop here. I don't need any of this. So what will be my truncation error? My truncation error, suppose TE, will be the exact expression of x, exponential x, that is e to the power x, minus summation of I equal to 1 to n plus 1 x to the power I by factorial of I. Okay. So this will be my truncation error. All right. Now Let's solve a few problems on this truncation error.
Sir,
Yes,
sir, actually, I have a doubt regarding WhatsApp group, sir. I
which
think in email, while joining the course, they have sent us a message. Will be providing mentorship.
sorry,
A group with.
I cannot hear you clearly.
Sir, actually, when we joined a course, we received an email from NPTEL department, sir.
Huh?
NPTEL team that
Okay.
we will be adding to a WhatsApp group.
I don't know about that actually. So you just mail them and or contact them someone
Sir,
and ask them
actually, I
about.
mailed them, sir. Actually, I
I
mailed them, sir.
I don't know about it. Sorry.
Okay, sir. Thanks.
So here the truncation error will be e to the power x minus this thing. Now let's do one interesting exercise. So that prove that in the Taylor series expansion of any function fx, Rn equal to some symbol. I will tell what the symbol is. Delta x to the power n plus 1 in the limit delta x tends to 0. Now, so Rn is the so reminder. Rn is the rest of the term or the remainder term. So we can expand f of x naught plus delta x in this way. This is the normal Taylor series expansion. F of x0 plus f prime x0 delta x plus f double prime x0 delta x square by factorial 2 plus dot 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 f to the power n x0, that is the uh, nth derivative by factorial n delta x to the power n plus Rn x naught delta x. So why x naught and delta x? Because see, in all this term x naught is present and delta x is also present. So I have given the expression of Rn. So Rn is some unknown function which is function of x naught and delta x. Now suppose g of x naught delta x is equal to this f of x naught plus f prime x naught. So up to this nth term. Okay. So what will be the Rn of x naught delta x? It will be obviously f of x naught delta x minus g of x naught delta x. Okay. If I just subtract these two, I will get Rn x naught delta x. So what will be the result? The result will be f to the power n plus 1, that is the n plus 1th derivative, x naught by n plus 1 factorial, delta x to the power n plus 1 plus f n plus 2, f to the power n plus 2 x naught by n plus 2 factorial into delta x to the power n plus 2 plus dot dot dot. Now we have to show, we have, I don't know what is this term. Okay, so far I will explain it. So in the limit of delta x tends to 0. Now in the limit, so here I will tell what is the meaning of that term. So if I just put limit delta x tends to 0 in this expression, what we will get? So I will get that Rn x naught delta x by delta x to the power 1. Okay, sorry, just a second. So here I need to explain what is the meaning of this term. So I need to show that it has order of delta x to the power n plus 1. So what is the meaning of this symbol? So this is called O, some big O kind of thing. It indicates the order of magnitude. Okay. So how to visualize this? Suppose you have a, so if you have a number, so suppose epsilon is a small number. Epsilon is tends to 0. Okay. And f of epsilon is some function, maybe sine to the power 4 epsilon. Okay. Now we can say that if epsilon is of, you see that this is not completely O, this is this is probably Greek O, maybe something like that. This is O. We represent it to tell that order is order of g epsilon only when limit epsilon tends to 0 modulus f epsilon by g epsilon is equal to some finite number. Just let me tell you an example of it. Suppose sine of epsilon is equal to sine of, suppose f of epsilon equal to sine of epsilon, and g of epsilon equal to epsilon. Now I need, now the question is, if epsilon is of order of g epsilon when epsilon tends to 0. Now let's check that. Now limit epsilon tends to 0, modulus of f epsilon by g epsilon. This is the formula. If this is a finite number, then this is true. Otherwise, it is not. So so what I have in the f epsilon is sine of epsilon, and g epsilon is epsilon. Now in the limit, now when epsilon is very very small, so what is the expression? Epsilon minus epsilon cube by factorial 3 plus epsilon to the power 5 by factorial 5 minus dot 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 by epsilon. So if I just divide it and just use the limit, you will see that the number will appear 1, and which is a finite number. So if epsilon is of order g epsilon when epsilon tends to 0. So I hope the idea of order is so far clear with you. If you have doubt, you definitely ask me. So again, just go through it once again. So we can say that if epsilon is of order of any other function g epsilon, when limit epsilon tends to 0, the absolute value of f epsilon and by g epsilon is a finite number. Okay. Now here I have given an example where f epsilon is the sine epsilon and g epsilon is epsilon. And now if I apply it to the rule, I get that this value is appearing to be 1. So we can clearly say that f epsilon is of order g epsilon when epsilon tends to 0. Alright. So let me just remove it. Okay, then again go back to the problem. Now the question is, we have to show that Rn is of order of delta x to the power n plus 1. So what we have to do? We just need, just have to the limit delta x tends to 0. Here delta x is working like that epsilon in the definition that I have shown earlier. So limit delta x tends to 0, Rn x naught delta x by delta x to the power 1, because I need to check if Rn is of order of delta x to the power n plus 1. So this is like g epsilon. Okay, so I am dividing it by delta x to the power n plus 1, and when I divide it, I get the result. Just on this thing will be left, f n to the power 1 x naught by n plus 1 factorial, because all other terms will be 0, and this is a finite number. So we can say that for the Taylor series expansion, the residual term is of order delta x to the power n plus 1. Alright. So if you have doubt in this question, you ask me. You will find this idea of order in the later in the course, where you will use a different method to solve differential equations and other problem. You will see that some error is of order h square, h is a step size, some other error is of order h. This order business will come at that moment. Okay, so that's why I am telling you briefly about this truncation error here. So now this is an exercise. So expand e to the power x and find out the value of the truncation error of order delta x to the power 4. Okay. So how to do that? So here e to the power x, this is exp of x, is equal to 1 plus x cube by factorial 3. Now the truncation error will have is of order delta x to the power 4. Okay. So not plus some residual term r. Okay. Now we need to check if r is of order delta x to the power 4. Here instead of delta x I have written x. Okay, this is the same thing. So what is, so suppose, so how to solve that? Let us assume another function f of x equal to 1 plus x cube by factorial 3. Okay, if I just subtract this, then what will be r? R will be e to the power x minus f of x equal to x to the power 4 by factorial 4 plus x to the power 5 by factorial 5 plus dot dot dot. Alright. Now I need to check if r is of order delta x to the power 4. Remember, instead of delta x I have written it x. So x delta x in this problem, these are all delta x. Okay, delta delta. So to check that, what we have to do, limit delta x tends to 0 r by delta x to the power 4. So what is the value of r? Is equal to limit delta x tends to 0 delta x to the power 4 by factorial 4 plus delta x to the power 5 by factorial 5 plus dot 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 by delta x to the power 4. So the answer will be 1 by factorial 4 equal to 1 by 24. It is a finite number. So the error is of order delta x to the power 4. Okay. So the correct truncation expression will be up to this, and beyond that everything is of order, or error is of order delta x to the power 4. Okay, so this is the correct truncation. Okay. Okay, now let's solve these problems. So already I have told that in the limit of epsilon tends to 0, sine epsilon is of order epsilon. Okay, so I have shown you how to do that, how to understand that. Okay, now can you tell me about these two? Are these true? These two example. Just take a few moments and tell me if these two are true or not. May- Anyone?
Yes, sir, doing.
Okay.
So
Okay. So
second one is true, I think.
second, you think second one is true? Okay. So let's check. So limit epsilon tends to 0, 1 minus cosine of epsilon by epsilon.
No, sir, it's false actually.
It is, you are saying that it is false. Epsilon, it will be epsilon cube. Okay, so let's check. Tends to 0. So 1 minus what? So what is the expansion of cosine epsilon? 1 minus epsilon square by 2 plus epsilon to the power 4 by factorial 4 minus dot dot dot. Okay, so this is epsilon cube. So it is limit epsilon tends to 0, epsilon square by 2 minus epsilon to the power 4 by 4 plus dot 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 by epsilon cube. You see that here is one epsilon, there will be one by epsilon term in the limit epsilon tends to 0. So its value will blow up infinity. So there is no finite value available. So this is not a correct option. So 1 minus cosine epsilon is not of order epsilon cube. Now when now so then what will be the correct answer? Instead of epsilon cube, if you just write epsilon square, okay, then you see that this thing by epsilon square, then this answer will be 1 by 2, and this is and this is a finite, and this is a finite number. Okay, so 1 minus cos epsilon will be of order epsilon square. Now if you proceed similarly, you will find that sine epsilon square is not of order epsilon. Okay, it is of order epsilon square. Okay, the same exercise, just try. Okay, so far, okay, so so far I have covered some of the theoretical part. Now let's go to the coding part. Okay, coding part means the only I will show you some examples and some aspect of using loop. Okay, so okay, let's do the some coding about the bisection method. So let me mm, yes, so like the last class, I have again solved the problem here, but here I will discuss it. So if your Matlab open, just try these things. Okay, so the all the examples are based on bisection method. Okay, what was taught in the second week. So how we solve that? So suppose we have a function, some arbitrary functions. Let's pick some arbitrary function like this. So you pick 2 points A and B, and you calculate the value of this f of a. This is f of a and f of b. Okay, and you then check if f of b is less than 1, sorry, less than 0. That means if this number is negative or not. When if it is negative, then one of them is positive and another of them is negative. So the root must lie somewhere in between those two limit. Okay, so obviously the first guess will be a plus b by 2, then we get somewhere around here. Suppose, okay, then this point is supposed to add a c. Then I calculate fa fa into fc. If it is greater than 1, that means if fa and fc and fb and fc. Here you see that here for this particular toy example, fb and fc will have the same sign. Okay, because fc is greater than 0, fb is greater than 0. Then we will eliminate this b and treat c as b. Okay, then again, so suppose we make this c to b, that means it becomes b. We don't need the shit, we don't need this thing anymore, because this part is solved. Now we have made our domain smaller, and we will calculate between these two. Again the same exercise, I will calculate fa fb. If it is less than 0, then the root must lie somewhere in between these two limit. Okay, then this way we will continuously reduce the limit, and at a point we will get the answer if the root exists. Okay, so here I am doing exactly the same exercise. Here So here my function is fx equal to x cube minus exp of x. Okay. Now to check what will be the initial guesses, because we have to provide two initial guesses, right? Because a and b, we do not know them a priori. We have to provide it to the, we have to provide it, and to provide that we need some, I mean, we need some intuition, some idea. Now to get the idea, so what I did, I first plot the function. Okay. So just to understand what will, what can be the, what can be possibly the limit. So if I just draw a horizontal line from 0, so this point will appear nearly around, so this is 5. So this is I think nearly around 2, maybe 2 or 3 somewhere. That was maybe 3. Okay. And here it is, so the root is around 3 most probably. And here we can see this value is clearly positive. Suppose that this is at 4 and this is at 0, it is negative. So this is, these two are my two good initial guess, because for one initial guess, suppose a equal to 0, this value is negative, and for a equal to 4, so for b equal to 4, this value is positive. Okay, so this is my starting point, where I am, where from this point I will start my coding. So we get the idea from the plot. So what will be the initial guesses? So a supposes 0, b supposes 4. Okay, then I will do repeat this operation of fa and fp, and we will check if it is less than 0. Then we will shrink the domain by making an average of, by taking and say taking the third point as the average of those 2 points. Okay, so then, so here these two are my initial guess. I have taken b equal to 3. Okay, so a equal to 0, a equal to 0, b equal to 3. Now check fa fb. Okay, now here here these are few new comment that I will, that you have to learn. Just a second. If printf print something for, okay, anything. So here, now to print, you have to put it under this semicolon, this colon. Okay, this quotation. When you put something inside the quotation, Matlab will understand that this is a string. You see, value of fab is something, I will talk about it, but you see that it has printed value of fab. Okay, because Matlab is, so because as I have put it under quotation, then Matlab will think that this is not some arbitrary variable. This is a string, and Matlab will print it for you. Okay, so if printf does that, but you have to put it under inside the quotation. Now here this percentage, say percentage e. Okay, percentage e is associated to this fa and fp. Okay, now fa fb, it, I don't know if it is an integer or not. If it is an integer, then instead of e, we should write percentage of d, because it will indicate the integer number. Percentage of f will indicate the floating point number. Suppose 0 0.5, 0 0.7, 0.8333. These all are corresponding to this percent f. Okay, and his this e just convert this floating point number to the scientific notation. Okay, so here you can see that minus 6.9144, this belongs to this floating point, this float. But here, if you want to write it in, say, in the scientific notation, just write percent e. Okay, here e to the power 00 means 10 to the power 0. Okay, in Matlab e indicates 10. E to the e plus 00 indicates 10 to the power 0. Okay, and here this slash n, that means you will the next thing will appear at the new line. So when you print it, Okay, if you don't put this slash n, suppose okay, suppose if print f, okay, so you want to suppose write two thing on the two different line. You just like this apple and then orange. If you just do this, it will show apple then orange. Now if you just put a slash in, what it will do, the orange will appear at the new line. So this is the meaning of slash n. Okay, all right. Now let's go to the code again. So you see that the value of FAFB is minus negative. So FA is positive and FB is negative, or vice versa. FA is negative and FB is positive. Okay. So value of FAFB is minus this. So the next case will be this 0.5 into A plus B. So this is A, this is B. I am taking the average at the midpoint of this A and B. So now here this max it. So I have to iterate it many times, okay? Because I do not know what will be the correct solution. So I need to do iteration so many times. So here max it indicates the maximum number of iteration. Tall is the tolerance, okay? So here, so you already know that we cannot get an exact answer in Matlab or any this kind of, when we are doing something numerically, you cannot get an exact answer. So in that case, there will obviously be some error. Okay, here I am telling it. Here I am telling telling Matlab what is the error. So here tall is similar to x minus x star. Okay, this is similar to this. So this is the physical meaning of tall. Okay, so if my error is less than this, this is the upper limit. If my error is less than 1e minus 4, 1e minus 4 means 10 to the power minus 4, then I am satisfied. Okay, then it is the correct root. This is not the exact root, this is the approximate root, but the difference between the correct and exact number is 10 to the power minus 4. So this is very, very small and I am satisfied with it. You can put 1e minus 4. If you need more accurate answer, you can put 1e minus 6, 1e minus 8, anything. Okay, now a now here a loop. I am using a loop. This is while loop. So the syntax is while something, if it is true, okay, while true, then the loop will work. Okay, and at the end, and after doing the work, you have to put an end to it. So this is the syntax of that. While some condition is true, that means suppose while 2 is greater than 1. Okay, and you can try this f print f, sorry, 2 is greater than 1, so this is always true. Then here you are writing your code, you are inside the loop, you are writing something. If and what is the command? F print f. That means I am telling the computer, if this is true, then do that. F print f, suppose apple. If this is true, then print apple and end. If you do this, you will see that your computer will print enormous number of apple. It will appear like that. Okay, unless is because this is always true, and you haven't put any bound to it. If it is true, then just print it. Your computer will continuously print this apple unless you forcefully stop it. Okay, this is called infinite loop, because the result appear infinitely. Okay, and if you like raise this 1 is greater than 2, this is false, then your computer will not show anything. Okay, because it, while this is false, then just end. From this step, from this step, it 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 do not go, it doesn't go to this step. From this, it just jump to this, because this is, but because this is not true. Why it will go to this step? If this is true, then only it will enter inside the loop and do the operations. Okay, so this is the basic syntax for the while loop. So when you do the, you use loop, then you will understand it better. So so just, so let's do the problem. So the, here my condition is, while, so okay, so another thing, conv is some number. Okay, conv is my initial guess of x minus x star. So suppose so here I am taking an initial guess, so I don't know at the end the error will be 1e minus 4, but at the beginning I do not know what is x star. So at the beginning I am guessing that my initial error is 1. Okay, you will see how it proceeds. And it is less than maximum iteration. So here my maximum iteration is 100. Okay, so what is the meaning of this symbol? So when conf is greater than tall, that means here conf is 1, that is my initial error, initial guess error is greater than tall, that is 1 to the 1e minus 4. Then the loop will run. This is called AND. Okay, I will talk about in detail later in the later live sessions. This is called AND. That means when conf is greater than tall, it is true, and it is less than max it. Okay, so in normal language it is called and to tell it MATLAB, you need to use this syntax, double ampersand. Okay, after practicing, you will be habituated with it. So when you have to use this double ampersand, double equal to, this thing will appear again and again. So don't worry about it. Just understand the logic and try to do it at home, the code. So while conf is greater than tall, just understand in the normal language, in our normal language. Okay, when this is true and when this is true, obviously my first iteration will be 1. I am starting from 1. Okay, and it is less than max it, and it is obviously less than the maximum, it is obviously less than the maximum iteration. And when conf is greater than tall, conf, what I have said, that conf is my, you will understand what is conf, okay, in a moment. So if fa into fm is less than 0, okay, then okay, now it is the good time to draw the plot. Suppose this is the function. Previously it was b and this was a. Okay, now the condition, if fa into fm is less than 0, here suppose somehow it will be my m. Okay, this is fm. If fa into fm is less than 0, if it is true, then b equal to m. Okay, and end it.
Excuse me, sir.
Ah,
So sorry for the interruption.
yes.
Sir, this derivation sir has explained in our video.
Hmm.
Just we wanted one example, sir. We have got an assignment question regarding this bisection method. They have asked for the relative error. Can you, if you just have the time, can you solve that problem, sir?
No, I cannot solve the assignment problem. I will what I have done, I can give you hint. So
Okay.
uh, I can solve the present assignment problem because you have to do it. What I
No,
will
we
do,
have already solved. Actually, I have got the wrong answer for that. So where will we get the solution for that, sir?
it will be shared. It will be shared.
It will be shared, sir. Okay. Sorry. Thank you, sir. Thank you.
Okay, so the first condition is, if fa into fm is less than 0, then your b will be m. Okay, so and this is the condition. So this is called the if else loop. And the second condition is if b into fm is less than 1, then a equal to m. Okay, and end. And again, so see in this two comment what I am doing, I am replacing m in terms of a or b. Okay, so I have m am or mb. I will have this. So in this case I am replacing m with b, and here I am replacing with a. Okay, and again what I have to do, so again what I have to do, m equal to 0.5 into a plus b, again the same thing, because I have to repeatedly do this thing. And here is conv. Okay, now here you will understand it. So you see that when you are doing something, so in Matlab, so previously you have to predefine some value to it. Okay, you can put 0 to, you can put 0, you can put 2, you can put 100, anything to conf. Okay, you don't have to put equal to 1. You just need to start the while loop. Okay, so and it is one condition to start the while loop, so I have used conf equal to 1 because it is anyway greater than this top. So I am use conf equal to absolute value of fm. Okay, now what is my f of x? My f of x was this. My f of x was this number, this value, x cube minus f exponential of x. And I am trying to find the root of this function. Okay, so whatever I got, suppose f of m, and this m will be my root. When f of m is 0, then this is the solution. And what will be the corresponding error? Absolute error will be modulus of fm. So I am using it at my conv. If this is close to 0 or less than this tall, then I will stop the loop, my while loop. So here I am using conv equal to abs of fm. So this indicates the absolute value. And after that, it equal to it plus 1. Okay, and then if it is conversed already, then it will go out of the loop and do something. And if it is not conversed, then it will run inside the loop again and again until any of this condition dissatisfied. When any of, suppose if it becomes 101, then the loop will stop. If convergence, if conv becomes 1e minus 6, then again the loop will stop. Okay, now when I print, now suppose after that you just do this thing, root equal to root equal to this percentage f. Then because the root will be obviously be some we cannot get an integer, we cannot hope to get an integer as a solution, so we'll get some floating point. So I am using percentage f. Iteration now, and iteration is a integer. Okay, so I am starting with 1, it will be 1 2 3 4 something like that. Iteration equal to percentage of d, and conf equal to percentage of e. So it is in the scientific notation, comma m it conf. Okay, so it will print. Then you see that root will be correspond to this m, because m will be my final root. It appears as 1.1.857193. This is the solution for this is the solution for this function x cube minus e to the power x. And see how many iterations, the total number of iteration is 16. Okay, and the convergence is approximately 3.6 into 10 to the power 5, and which is less than 10 to the power minus 4. Now consider these two things very carefully. Now here iteration is 16. It is much less than 100. But here you can see that here my absolute error is less than tall. And I have used the condition that any of this condition is, if any of this condition is not true, then while loop will stop and show you the result. Now after 16 iteration, I have got satisfactory convergence. Okay, now here the value of convergence, that is conf, equal to 3.6 into 10 to the power minus 5, which is less than 10 to the power minus 4, That's why the while loop stopped calculating, and after that I am using this fprintf and I am getting the final solutions. So if you have any doubt in this thing, you just ask me. Otherwise I will go to the next example. So probably many new things you are learning in this thing. If you are new to, if you are new to MATLAB, just go through this type, go through this, just understand the physics, and everything else you will just find in Google. Okay, all these things is Pramani.
Sir, I was asking that due to some problem I couldn't join in the right time.
Huh?
So, sir, can I get the this recording? Like the last recording was given after almost 7 or 5, 6 days.
Huh.
So,
So actually, the process is I have to I am recording it. I will share it to the NPTEL team.
okay,
Okay,
sir.
and they will share it to you. So this is the process.
Sir, but can is it
Uh-huh.
anyhow possible?
Yes. So another thing. So you will see that if you see the recording of the last class, I have to put it in my YouTube channel.
Yes, sir, I've
And
subscribed to that channel also.
yeah. So I will put this recording in the YouTube in the new YouTube channel tomorrow. So tomorrow by tomorrow evening you will be able to see it.
Okay, sir. And sir, one more thing to disturb you. Sir, actually, the last assignment that we have been given, the marking, according to that assignment, the marking that I have got, I have a doubt in two questions. So,
Actually, there are other TAs who deal with this assignment things. Okay.
okay,
So just write in the group discussion, or maybe if you have a provision to write them an email, do that.
okay, okay, sir. But sir,
Okay.
just like asking,
Huh.
can you just, look into the matter because I couldn't do that, so that was also a problem. So I left that blank also.
Okay.
If
So
you get the time after completion of this portion.
okay. 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 Sure.
Thank you, sir. Thank you.
So you are not still getting access to MATLAB. Uh,
I wrote them.
I have also seen many things about in the. I have also seen some arguments about in the Google group. Oh, hmm. Okay.
Sir,
Yeah. Actually, I will write it to them, but okay. I will ask them. Sure.
sir, have you looked into my problem that I showed?
I have looked at it. I will tell you. Just let me finish this.
Yes, sir, sure.
Okay. So this bisection, I think this idea is clear. So next, go to the next problem. Same thing. Here the function is x cube minus sine x. Okay. So here I am so fast. I am plotting it. Okay. I don't know what will be the. So obviously x equal to 0 is a solution, but I don't want to find the trivial solution that is x equal to 0. I want to find some other solution. So I first am plotting this thing to get an initial guess. So here my guess is a equal to 0.05 and b equal to 1, because at a equal to 0.05 it is negative, and at b equal to 1 it is a positive number. Okay, just 1 second. Let me just save the recording. So again the same thing. Check if this value is less than 0, so it is less than 0. So now I can proceed. So first step, take an initial. So take the so this is the initial m, 0.5 into a plus b. Again the same thing, max seat tall equal to 1 to the power minus 4. Conf, like I told that you can take any value to conf, but you have to define something. Okay, so just to start the iteration. Don't take 0 because 0 is less than tall. Okay, so take some arbitrary value. So I have taken one. You can take conf equal to 1,000, anything. It is just to initially start the loop, and after that it will come out as your absolute error. Okay, so conf greater than tall, the same thing. This is also the same operation, and I am doing the same thing also. This is the conf. I am taking the f minus f star, here f is equal to 0, the final, because I am finding a root. You can define your error like something like x minus x star, something like that. I have found that this will be convenient for this case. You can try any other thing. So here conf equal to abs of fm. Abs is the absolute value. This is how to write absolute value in Matlab, and it equal to it plus 1. And after that, just do the same thing. Here the root is 0.928662. Iteration is 14. It is again much small than 100, and this is the error. This is the convergence, the error. Yes, so
Sir, theoretically, the iteration must stop in step number 99, I think,
now why?
because iteration it less than max of it. Max of it is here 100,
Right.
and so 99 is the maximum integer that is
Yes,
less
yes,
than.
yes, yes. But this condition is already satisfied, na? This is no longer true. You see that conv is what? Is 10 to the power minus 6, and tall is what? 10 to the power minus 4. So it is no longer true. So this is false after 14th iteration. So the loop stopped there.
Yes, sir. Sir, I understood this one, but I am talking theoretically that if it is going on and on.
The, in so if you want to do that, instead of this double ampersand, conv greater than tall, or this is or it less than maxit, then it will go till 99. Okay, so this is similar to the idea of the set theory, intersection and the union. Okay, if
Yes,
both
yes.
of these true, then only it will happen. If either of these true, in case of this, if either of these true, then the loop will work. Okay, we use this and or this symbol according to the problem. Okay.
Sir, in keyboard, how we can use that or sign or symbol, that one?
No, this is just above the enter. You see, so in my laptop, it is just above the enter. There is a slash. Another is a vertical line. Just use two vertical line.
Okay, okay, okay.
Hmm. Okay, so this is another example. Okay, here the simple function, just to show that in case of simple function also, it will take time to converge. So the function is x minus 3. I am doing the same operation. Yeah, so here is another thing. Okay. Mhm. Right. So suppose you take your initial guess wrong. Okay, suppose a equal to 0.05, b equal to 1. Here fx equal to x minus 3. So here, so f of 0.05 is less than 0, f of 1 is f of 1 is again less than 0. Okay. So now the value of fb is greater than 0. Right. Now if I just do the code. Okay, so here what was you saying? You see that here the root, so this is not a valid answer. First of all, the correct answer is 3. Here you see the iteration is 100 because it didn't converge, and if I just take max, it is 1000, 10,000, it will go till that point. And here conv is again, it is always greater than 1 e minus 4. Okay, so because we just took two initial error value. So neither of this algorithm worked. Now in order to rectify that, what we can do, we can do some modification. We can do some modification in our code. Okay. So see that this is the small modification. I am doing all this thing, it equal to one same thing. Okay. And now just before, now I have put some condition in writing the root. Okay. So if conf is greater than tall, okay, that means, so I will write f printf, because if this is 2, so 2.45, but I want my error to be 1e minus 4, that means 10 to the power minus 4. So this is this is not the correct root. So I am using that condition. If conf is greater than tall, then f printf no root, otherwise else f printf that thing. So it will print just no root. Now if you take your initial guess something else, suppose x equal to 1, sorry, a equal to 1 and b equal to 4, then it will converge very smoothly. Okay. Then you will see that you will then it will go to this next thing, and it will show you the root, the iteration, and the convert, and this convergence value. Just similar to the other two examples. So this is the slight modification that I am doing in the code. If conf is greater than tall, then just print that the no root for those initial conditions, because this bisection method is very dependent on the initial conditions. And else, just print the correct answer. Okay. Okay. So this is what I have planned for today. I will share both the documents with you. Now coming to the Soham's questions about solve solve x cube minus something plus x to the power 4 plus x to the power 5 equal to 0, this kind of thing. Why it doesn't work? The actually it doesn't work. So in the example you show, so if x to the power 4 minus 1 equal to 0, Matlab works very well if I use solve. Now suppose it doesn't work for this, it will show you some root, then something in terms of z cube plus z to the power 4 plus z to the power 5 comma 1 comma 2, something, it will show something like that. It indicates that Matlab is not able to solve the problem. Okay. Because why? Because we do not know all analytical solution of all expression. It is impossible to know. Suppose we have something expression like x to the power 100 plus x to the power 69 plus x to the power 17 plus 3 into x to the power minus 12. Maybe it is plus something 10 to the power 5 equal to 0. Okay. Then we will always able to find a numerical solution to it. Okay. But not always the analytical solution. Suppose we are why we are, so here you will understand better. So last week the finding the root of the nonlinear equation started. So in the next week also you will learn about the Newton-Raphson method. So so what is the need of all these things? If we can find all the expression analytically, then we do not need to bother about doing all these things, because it takes time. The bisection method takes time to convert. We have to specify the initial guess correctly, otherwise it will not convert. So there are many problems. But if we can do something very simple like this, x to the power 4 minus 1 is x square minus 1, x square plus 1. So we can find out, if we can do something like that, then it is very easy. Analytical solution is very fast. But it is not always possible to solve analytical solution. Okay, there may be always a numerical solution to it, right? Like we are trying to find. There may not be any analytical expression for something like this, x cube minus sine x. Maybe I don't know. So no, sorry. Suppose e to the power x cube minus sine x equal to 0. If I try to find the root using the bisection method, I will be definitely able to get that. But using all these methods, but using analytically, I am not sure. Okay, so Matlab is facing that thing. If you feed him some expression which cannot be analytically solved, it will show some garbage, something like that. Okay, root, and in terms of z, then some comma 1 comma 2 comma 3 comma 4, this kind of thing will appear. I think it solves your doubt, Sean.
Yes, sir.
Okay.
Thank you, sir.
Hmm. Yeah, so Pramanik, you can tell.
Hello, sir.
Yes, yes.
Okay, sir, I was telling, can I show you the numerical?
Mm-hmm. Sure.
Okay, sir,
Just a second.
yes, sir. Just 1 second, sir.
Hmm.
Sir, can you see the screen?
Yes.
Okay, sir, this numerical, I have got it wrong. Uh, I couldn't do that in any ways possible.
If
So,
x equal to e to the power x minus e to the power minus x by x. This is the answer. So okay, so this is the question. If we evaluate f(0, 1) by replacing each exponential function which is Taylor polynomial, the actual value is 2 point something. What is the relative error? Okay, relative error, right? So so what will be the expansion? So e to the power x minus e to the power of minus x. So the Taylor function, Taylor expansion will be equal minus x equal to 1 plus x squared by factorial 2 minus of 1 minus x plus x squared by 2. So the so if you go up to x square, is up to the third term, I mean the x squared term. So e to the power minus x minus of e to the power x will be x square, right?
sir,
Huh. So then it will be x square by x equal to 0.1. So equal to x and the value of x is 0.1. Right.
but sir, it is not coming 0.05. I've tried many times. I have tried with one iteration, I've tried with two iteration, I've tried with three iterations also. From starting from third iteration, this answer they are returning this answer. So this is the same question, but with three iterations, I'm getting this value. But with the any iteration of less than like three, like two iteration, there is 0.00333 and divide by, so it's coming as one because two iterations is returning only two, sir. And for the other cases, the value is not so much to get 0.05. I've tried many times, so it's not happening.
Okay.
That's why.
Then if you are doubt, then you can raise the question as a Google in the discussion forum.
Answer one more question, sir. That is, uh, in this question, uh, yes, sir. Sir, here it is clear that uh, there are more than one error because there is a colon sign here. I don't know whether you can see. Okay, let me try one more. So can you see that now?
Just a second. I can see it now.
Okay, sir. And sir, this is a matrix. So this is also a matrix. This is also a matrix. So this is one error which is clear from here. And sir, as C is getting multiplied to A, and we need the elements to get multiplied, there should be a dot here. So I think two errors are prominent from this
Just
question.
just a second. C dot star B, A dot star B. Okay, okay. So C into A. C will be again a column matrix, right?
Yes, sir.
So you cannot do C into A. Okay, okay, so this is one error. And what is another error?
Another error is sir this one.
This No, that is not an error.
This is not an
No,
error.
no.
Okay, okay. What does this do, sir?
That is so. Okay, so then I think C into A is also correct. So the correct answer is no error, right?
But sir, the answer is accepted errors. The answer is scored no answer. The answer one. So this is
Actually,
there is one error they are saying.
there is one error. Okay, okay, so go up. Yes. 1 colon 2 colon 3 prime. That means prime. Okay, that is not an error. So C equal to, oh, okay, A dot star B. A dot star B. 1 second, Shom. A dot star B. Okay. Okay, so let me just again share my screen. Okay.
Sir,
Hmm.
Sir,
when we are putting A dot star B, that
Hmm.
is not defined because the dimension is not
Hmm.
matching.
Okay, so it is showing undefined. A dot star B.
Yes, sir, because 1, 2, 3 is row matrix and one
Right,
and
right,
B is
right, right,
column
right, right,
matrix.
right. Yeah. Mm-hmm. It will show an error, right? So to help show to help Pramanik, so okay. Yes, so suppose your A equal to 1 colon 2 colon 3. It will be your 1 2 3 column vector. Now if you put a prime, then your A will be 1 2 3. This is transpose.
okay, sir. I didn't knew that it was.
So yeah, this is transpose. Okay. So whenever get something like this, just type it in Matlab. Then you think it will be easier for you. So
Uh, so
this
then the only error is C dot star. That one is the only error.
C dot star. Yeah. So
That
that, yeah, there will be a problem in the dimension, right? Because C is a so one is a column matrix, another is a row matrix. So there will be a problem in the dimension. But if you remove this thing, okay, and then it is dimensionally consistent. Then what we see? C is 3 cross 1 and A is 1 cross 3. So you can easily multiply C into A. If you remove the dot at that point, then it will be 3 cross 3 matrix. Okay.
but sir, with the dot, it will return error.
It will return error because it has to be dimensionally consistent. Here you are adding multiplying term by term, so it has
Okay.
to be dimensionally consistent. Huh?
That means sir, C star A means only matrix multiplication, and C dot star A means multiplication of the elements.
Right.
Oh, okay, okay, sir. I thank you, sir. And sir, the last one that is I should mail to them, right?
If you have doubt, so I have to calculate that thing in order to get sure. But if you have doubt, you just write in the discussion forum, or they will upload this assignment solution. I think in a week or two. They generally upload it with after completion of this of second week. So this is the second week solution, or that's first week.
Second week one.
Second week solution. So yeah, so they will upload the answer. You can check it there as well.
Okay, sir, and one more thing. Sir, have you seen the last day problem with the complex plotting?
Yes, I was forgetting something. Yeah, so can you just tell me that thing again? So what was the issue?
Sir, actually, I'm not doing it from my PC, which has Matlab. I'm doing it from my friend's house.
Mm.
He doesn't have any software like that, so I don't have
No,
it
no,
here.
no. Just tell me the problem.
Sir, I don't remember it properly, but it was something like plotting something which has a solution near to some points, something like that.
Okay, so tell me in the next week, next Sunday. Huh?
Okay, sir. Okay, sir. Thank you, sir.
Okay, okay, okay. Okay, so goodbye, good night. Hmm.
Thank you, sir.
Okay. Good night, sir. Thank you, sir.